Good morning and happy Saturday from Mahia, New Zealand, where our Electron rocket is ready on the pad at Rocket Lab's Launch Complex 1 as we count down to its 11:01 a.m. local time liftoff for today's mission. On board Electron today is our return customer Kineis as we prepare to launch the second of multiple launches for them to deploy their Internet of Things constellation to space. My name is Prachi Saknani, and with me is Andrew Haig, and together we are live from Mission Control Center in Auckland, New Zealand for our 53rd Electron launch.
Well, thanks, Prachi. It's great to be back on the pad with Electron again so quickly after we stood down from our launch attempt earlier this week. Now, a ground system sensor triggered Electron's flight computer to safely halt the mission right on T0 for that last attempt. But with Electron, the launch pad, and Kineis' payload all healthy and ready for another launch attempt, we're back on the pad and ready to try again today with greens across the board so far for our pre-launch operations.
Coming up shortly will be the go, no-go poll run by our launch director to check with each of the operators that their system is prepared and ready to continue the countdown to liftoff. We have operators, as you can see, in our range control center and in our mission control center on your screen. The go, no-go poll is scheduled to start at T-minus 12 minutes, so only with a few seconds left on the clock. Let's listen in to the audio channels for the update.
All stations LD on mission, proceeding with the go, no-go sequence. Stage?
Stage is go.
Avionics?
Avionics is go.
GNC?
GNC is go.
VCon?
VCon is go.
T1?
T1 is go.
GC?
GC is go.
PLS?
PLS is go.
RSO?
RSO is go.
MET?
MET is go.
MM?
MM is go.
And LDSUP?
LDSUP is go.
Okay, the go, no-go sequence is complete. We are T-minus 11 minutes, 19 seconds, and counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
So good news there from today's launch operators. We're cleared to move forward with the final pre-launch operations. Today's mission requires an instantaneous launch for the satellites in order for them to be in the correct orbital parameters for the constellation they're joining. And that T0 is set for 23:01 UTC, which is 11:01 a.m. local time for today's liftoff.
In just 10 minutes and 35 seconds, Electron will be sending the Kineis-killed the RadIOT Star mission to low Earth orbit for Kineis, an international space-based solutions provider to improve global Internet of Things connectivity. This is our 53rd Electron launch overall, but our second for Kineis this year, just 3 months after we launched them for the first time from Launch Complex 1. That mission launched our 50th Electron rocket, with the first 5 satellites of their new IoT constellation successfully deployed to their new home at 635 kilometers above Earth, just 66 minutes after liftoff.
I'll be launching 5 missions overall with 5 satellites on board each time. And each launch is tailored specifically to Kineis' mission requirements. That includes instantaneous launch windows, like for today's mission, but also a precise payload deployment, first with a single satellite and then in pairs to build out the constellation exactly as Kineis needs it. Now let's hear more from the team at Kineis.
Kineis is a French company based in Toulouse. We are a satellite operator and a global connectivity provider dedicated to the Internet of Things. Mountains, ocean, deserts. 85% of our planet has no network coverage. In 2020, we raised a large amount of 100 million euros to address this global issue. Today, we are following through and will deploy a constellation of 25 nanosatellites that will enable us to connect to a multitude of objects anywhere on the planet in near real time. We are convinced that this transmission of information made possible by satellite connectivity will enable us to respond to crucial challenges for mankind, its activities, and its environment. On the environmental front, for example, Kineis connectivity can detect a fire outbreak in less than 15 minutes, thus considerably reducing the extent of the outbreak and reducing the loss of property and human life. The same goes for monitoring water levels to prevent flooding and use this dwindling resource. The applications are endless, whether for locating, monitoring, or alerting. Since the creation of Kineis in 2018, our teams have been working with this objective in mind. Our 25 nanosatellites that weigh only 28 kilograms are real technological gems. The retractable UHF antenna, for example, can hear a bird sing within a rock concert 650 kilometers from the Earth. We fitted them with thrusters to ensure they stay on track for their mission. Some even carry children's drawings. That's amazing. At the same time, we have deployed many ground stations worldwide and have a sovereign infrastructure to guarantee data transmission to our clients. Today, Rocket Lab is preparing to launch a new cluster of 5 satellites, marking yet another significant step forward in our mission. With 5 satellites already in orbit at 650 kilometers, each launch reinforces our ability to connect with the rest of the world and address the challenges essential for people, their activities, and their environment. We can't wait to take this next step.
It is great to be counting down to another Kineis launch. After today's mission, we have 3 more dedicated launches to build out their constellation. We are proud to be supporting Kineis with flexible, tailored, and direct access to orbit on Electron.
Now, speaking of Electron, with just 7 minutes left on the countdown clock, it's time to take you through a closer look at the rocket and mission profile for launch. Now, today's Electron rocket is our standard platform orbital launch vehicle capable of lifting up to 320 kilograms of payload to space. Electron stands at 18 meters or 59 feet tall and is primarily made with a carbon composite material, which is why our rocket looks black when it's not fueled. Now, Electron is the world's first carbon composite orbital rocket, powered by the world's first 3D printed battery-powered rocket engines to make it to space. 9 of these Rutherford engines are located at the bottom of the rocket's first stage, and a single Rutherford engine with an expanded nozzle is used on the second stage. Now, all of the Rutherford engines across the rocket use batteries to power their turbopumps, and Electron performs a unique launch maneuver called a battery hot swap that happens part-way through the mission to replace the second stage engines' used-up batteries for new ones. Now, across the first and second stage, the engines use a propellant mix of kerosene and liquid oxygen, and it's that second propellant's super cold temperatures that make the outside of Electron look white, because that's where condensation has turned to ice. Now, without the propellants, Electron weighs in at just over 1,000 kilograms, but when the rocket is fully fueled, Electron weighs 13,000 kilograms.
At the top of the rocket within its fairing is where you'll find today's payloads of 5 satellites for Kineis. As you can see, they're attached to the kick stage platform, from which they'll be deployed once they reach their destination. So, for today's mission, we are headed on a 643-kilometer orbit on a southern trajectory from Launch Complex 1. 2 seconds before T0, Electron's 9 Rutherford engines will ignite for liftoff, and the pad's hold-down mechanisms will be released, allowing Electron to travel upward for a short while before curving its path to continue its climb, but more horizontally. The rocket speed will continue to increase until it reaches max Q, or maximum aerodynamic pressure, just under 2 minutes from liftoff. Once it clears that first milestone, the next step in Electron's journey will be MECO. This main engine cutoff is when the first stage from the rocket shuts down and separates from the second, before the single Rutherford engine on stage 2 lights up to continue the mission to orbit. We'll have a repeat of that separation for stage 2 and the kick stage about 7 minutes later, and the kick stage will finish the mission by delivering Kineis satellites to orbit. Once that's done, we'll also have the kick stage perform a perigee lowering burn that will help reduce these stages' orbital lifetime as part of our effort to keep space sustainable.
All right, so there's just 4 minutes 20 seconds remaining in the count to liftoff for Kineis killed the RadIOT star. At T-minus 2 minutes, Electron's flight computer will take over the countdown and autonomously run through its final operations. A liquid oxygen will continue to flow into Electron all the way up to T-minus 1 minute and 30 seconds.
That's right, and after that, we'll hear confirmation that Electron's first and second stages are fully pressurized and ready for launch. And then it's over to our launch director, Michael Pearson, for the iconic 10-second countdown. For now, let's send it to mission control so they can send it to space, and we'll check back in with you after liftoff.
All stations LD on mission. From now, there should be no red flags on your critical LCCs. Beacon LD mission.
LD beacon.
Please lock auto sequence and confirm.
Auto sequence locked.
Confirm all expected primary flight computer ASGOs are green.
All ASCOs are green.
Okay, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
The vehicle is fully on internal power, AFTS is green and enabled for flight.
Lock's load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight. High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Stage 1 propulsion nominal.
T plus 35 seconds and counting, and we are well on our way to space. Our 53rd Electron rocket has taken flight, and it's headed to orbit with its payloads for Kineis. Up next, you'll hear the call from max Q, or maximum aerodynamic pressure, the point in flight where Electron experiences peak structural load. The GNC operator on console will give us the call that max Q is approaching, and then we'll hear for confirmation that we have passed through that gate.
Cleared max Q.
And there we have it. Confirmation Electron has passed through max Q. We are now at 19 kilometers altitude and traveling over 2,700 kilometers an hour. And next up, we have 3 key events: main engine cutoff, or MECO, stage separation, and stage 2 engine ignition. MECO is when all 9 Rutherford engines shut down to prepare for the next phase in flight. And after those engines shut down, Electron's first and second stages separate. Then finally, the vacuum-optimized Rutherford engine on Electron's second stage ignites to propel the mission through to an elliptical transfer orbit. Those 3 events all take place in a quick succession over just a few seconds, so let's listen in for those calls.
"15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
We are now T plus 2 minutes and 45 seconds into the mission, and as you've just heard, Electron has had a successful MECO, stage SEP, and second stage ignition.
Stage 2 guidance.
Telemetry data shows that Electron is now moving at over 8,200 kilometers per hour and has just passed 100 kilometers above Earth. Up next is fairing jettison, when Electron's nose cone, which is protecting our payloads today, will split in two and fall away. We might see this happen on screen, so let's keep an eye out for that.
Fairing jettison succeeded.
And that was the call out for fairing jettison from Mission Control, exposing the payload to space ahead of deployment.
Stage 2
Electron is
proposing
traveling at over 8,500 kilometers an hour at an altitude of 125 kilometers, with just a few minutes remaining in the second stage burn.
Now, if you take a look at the graph on the right-hand side of your screen, then you can see Electron's current trajectory compared with our expected trajectory. And we like those two lines to be as close as possible, and that's what helps Electron's precise payload insertion accuracy.
HV discharge nominal.
Some of you may be wondering how IoT satellites impact your daily lives. These satellites connect devices globally, even in areas without regular internet. In day-to-day life, this means you can track deliveries worldwide and carry out credit card transactions, even if you're stranded in the middle of the South Island of New Zealand. They also support things like your smart home assistant or fitness watch, allowing them to stay connected anywhere for real-time updates or alerts.
Now, one of the things that sets Electron apart from many other rocket designs is the use of electric pumps in the Rutherford engines. And those pumps
Guidance
are powered
is
by
nominal,
batteries,
200
which
seconds
deplete in
remaining.
power throughout the flight. Once we use up all the available energy in one set, we'll switch to a fresh battery to complete the mission all the way through to orbit. And that maneuver is referred to as the battery hot swap. Now, after the first set is depleted, Electron won't need those batteries for the remainder of the journey, so we jettison the depleted batteries to save mass in the final stages of flight. That's coming up soon, so keep an eye on your screen and see if you can see the shiny silver batteries eject and fall away.
HV discharge nominal, approaching hot swap.
Throttling down.
Battery jettison confirmed.
And that was the call for battery hot swap on the second stage, confirmed as successful by Mission
Hot swap
Control across
successful.
the nets. Up next is the final stage of Stage 2 flight, including SECO, or second engine cutoff, followed by kick stage separation. This is where the kick stage, carrying the 5 Kineis satellites, separates from Electron's second stage. That final engine cutoff is coming up just shy of 9 minutes, so only about 3.5 minutes to go.
Stage 2
AFTS has
propulsion
saved.
holding nominal.
Now, electric pumps on Rutherford offer other advantages other than just a simplification of design. Now, these groundbreaking pumps can run the tanks all the way dry, allowing the second stage to squeeze every last bit of performance out of it during flight. And those pumps on Electron's second stage are currently powering us at speeds of over 19,000 kilometers an hour.
Some keen watchers from Flight 50 will remember some fun flips and rotations the kick stage performed during payload deployment for the last Kineis mission. The kick stage's reaction control thrusters achieved this by expelling precise amounts of cold pressurized gas through small thrusters to rotate the kick stage and control its orientation and position in space. It's this system that's responsible for our industry-leading deployment precision.
It's now T plus 8 minutes 18 seconds, and we're fast approaching second engine cutoff. And just before that happens, the Rutherford engine will begin to throttle down in preparation for shutdown, which is scheduled to take place at around 9 minutes into the mission. So let's listen in and wait for that confirmation.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer
Great news
orbit
there from
achieved.
Mission Control. The second stage engine has shut down and the kick stage has separated and is about to enter a coast phase for around 45 minutes. At the end of that coast, the Curie engine on the kick stage will ignite 2 times to complete some final positioning maneuvers. The first will circularize our orbit to 643 kilometers, and the second will slightly lower our perigee at the customer's request.
Now, around a minute after the completion of that final burn, the Kineis satellites will be deployed in sequence. First, a single satellite will be deployed off the top of the kick stage, followed by the remaining 4 satellites deployed in pairs from opposing sides. Now, payload deployment is scheduled to take place just 55 minutes from now, so we're going to take a short break while the kick stage coasts around to the opposite side of the planet. We'll see you back here soon.
Welcome back to the launch of Kineis kills the RadIOT star, our 53rd Electron launch. Just over an hour ago, Electron lifted off from Pad A at Launch Complex 1 in New Zealand, carrying 5 satellites for French IoT company Kinéis. The satellites are now just minutes away from being deployed to their final positions in space. The Kickstage's Curie engine is performing 2 burns today, and while we were on our break, we've already had our first ignition and cutoff. This Curie burn lasted about 2.5 minutes to round out our orbit from its 643-kilometer apogee. We've mentioned Curie a few times this launch, and we've talked about our small but mighty engine prior to liftoff. But just how small is it? Well, check it out here.
Now, named after physicist Marie Curie, this extremely small engine is capable of some very big maneuvers. We've flown this engine on all but our first mission, and it allows us to raise and lower our orbits, perform plane changes on orbit, and it's responsible for our pinpoint payload deployment accuracy. Now, this version we have here is the Curie Mark III, and it's not just used on Electron's kick stage. This engine is used on a lot of our spacecraft missions as well. The Mark III engine used here is in the satellites that we're building for Varda's in-space pharmaceutical manufacturing, and we flew a variant of this engine to the moon back in 2022 as part of the Capstone mission for NASA.
With only a few more milestones left in this mission, the second Curie burn comes next, lasting just 8 seconds. This is a slight orbit adjustment specific to our customer's mission before the deployment sequence begins. The satellites will deploy approximately 45 seconds apart, starting with the forwardmost satellite.
Curie ignition confirmed. Curie engine cutoff confirmed.
Great news there to have Curie engine shutdown confirmed by mission control for the kick stage. Now, up next is our last mission milestone, the payload deployment for the next 5 satellites for Kineis' constellation. Each Kineis satellite is a 16U platform weighing about 30 kilograms or 66 pounds. As we've mentioned already, the 5 satellites currently attached to the kick stage will be deployed in a particular order. We'll first deploy the top spacecraft as the first event, and then we deploy the next 2 satellites that are attached opposite to one another on the payload structure. And finally, we'll do the same thing again with the last 2 spacecraft. Between deployments, the kick stage does some neat gymnastics thanks to our reaction control thrusters, so keep an eye over on the animation for that, and over now to mission control.
Final orbit.
Kineis, Payload 1, deployment confirmed.
And there it is, deployment of Kineis 1, the first satellite on this mission, is now on orbit. Our reaction control system, or RCS, will expel some cold gas to change our orientation, so we can deploy the next 2 exactly where they need to be. That'll be Kineis 2 and 4, followed by Kineis 3 and 5.
Kineis, Payload 2 and 4, deployment confirmed.
Stellar news there from mission control. Kineis 2 and 4 have been deployed and are now on orbit. Now, one more Olympic level flip for the kick stage, and then final deployment for this mission. Kineis satellites 3 and 5 up next.
Kineis, Payload 3 and 5, deployment confirmed.
And there we have it, the final 2 Kineis satellites, 3 and 5, are now in are now deployed. Mission success for Kineis kills the RadIOT star. Welcome back to orbit for our customers. Electron has added another 5 satellites to space for the Kineis constellation. We have another 15 satellites to go across 3 more Electron missions to complete the build-out of Kineis' constellation, and we cannot wait.
And we'll be back again in no time with the next Electron on the pad, so stay tuned to our social media channels for mission updates on the next launch. For now, though, we'll wrap up today's broadcast and see you back here soon. Thanks for joining us. This is Rocket Lab Mission Control, signing off.